I'm Anil Kumar. Welcome to my series on calculus. Here, we'll look into a very popular question on optimization. Consider the given figure to find the position of point P so that AP square plus BP square is minimum. We are given that CD is 20, A to C is 16, and B to D is 22. Now, this kind of a situation could be a real life situation also. Many times we have seen test questions where we need to have a gas station on a highway, which is to cater for two cities which are 16 and 22 kilometers away from the highway, right? Something like this. Or we have seen this question in cases where there's a watchtower and there's a fire in the forest, and there's a river flowing here. You need to get water from the river to extinguish the fire, right? So let's say this is the fire. So that could be another situation. So you can see that it has wide applications, right? AP square and PB square relates to the distance. So it could be minimizing the distance to travel and to get the job done. So those are the applications where this will fit in. Now let us see how to solve such questions, right? So we are given here the distance between C and D is 20. So let us assume that this is x. In that case, P to D will be 20 minus x, correct? And we need to minimize AP square plus BP square. This is what we need to minimize. So what is A to P equals to? Well, we can write AP square as sum of squares of 16 and x. So that is x square plus 16 square. And P to B, that square will be equal to 22 square plus 20 minus x square, right? So that is how we can actually relate AP square and BP square in terms of one variable, which is x for us, right? And we need to just minimize this. So let's find the equation now. So this could also be written as, now let me combine these two. So AP square is x square plus 16 square, and BP square is 22 square plus 20 minus x whole square. So let us expand this. We get x square plus, let's get all the values now, right? 16 square plus 22 square. When you expand this, you get 20 square minus 2ab, which is 40x, plus x square, right? So combining the terms, we get this distance. Let's call this as the distance, let's say some variable d. Okay, so we'll just call this variable as d. Okay, now so combining this, we get 2x square, and let me now minus 40x, let's write this and see what those numbers are. So the numbers are 16 square plus 22 square plus 20 square. That gives you 1140. So that becomes our equation, right? To minimize, we'll take derivative of this, right? And then equate it to 0 to find the critical number. So the derivative for this total distance, which is actually the squares addition, with respect to the variable x will be, this will be 4x minus 40. Now to find the critical number, this derivative should be 0, right? So for critical number, this should be equated to 0. So that means 4x equals to 40, or x is equal to 40 over 4, which is 10. So we get the value of x as 10. So that could be one of our answers, right? So that is the critical number. Now you need to check for minimum, right? So if you leave the question here, you have not justified that this critical number really represents the minimum distance square sum, you could say. So we'll find the second derivative for ensuring this, right? So what we know here is that this distance derivative was 4x minus 40. So what is its second derivative? So the second derivative is number 4. Now since this 4 is greater than 0, we know that the critical number represents minimum. So that is the second derivative test which confirms that the critical number is indeed minimum, right? So we get minimum is when P is 10 units away from C, right? Or you can say CP equals to 10. So that is how you could actually solve this particular question. So I hope you understand the method and also appreciate the situations where it could be applied. Feel free to write your comment, share your views, and if you share my videos, that'd be great. Thanks for watching and all the best.